So let's look at another feature of graphs called the horizontal asymptote. And we talked about that briefly on the front side of this worksheet. So a horizontal asymptote is a horizontal line that the graph approaches but never touches. As we move from the origin. Now, when I write in my vertical asymptote, I like to use a green pen because a horizontal asymptote could be an asymptote, but it's not always an asymptote. It's for at least one part of your graph. And I'll show you what that means when we get to an example. The rules for finding the horizontal asymptote is to look at the degree of the polynomial. And I'll explain this through the examples. If the degree in the numerator is higher, you'll have no horizontal asymptote. If the degree in the denominator is higher, the asymptote will be at y equals 0. And if the degrees are the same, you're going to divide the leading coefficients. So let me explain that. Notice on this one, the degree of the polynomial is the highest exponent, the exponent at the front. Do you see how these are both 2? So I would say this one is degree 2 and this one is degree 2. So I'm going to go up and find the one where they're the same. Since they're both x squared, I'm going to find my horizontal asymptote by dividing the leading coefficients. So 10 is the leading coefficient here, and 15 is the leading coefficient here, and then I'm going to reduce. So the horizontal asymptote is at 2/3. Look at the next one. This one is x to the first, and this one is x to the second. So the degree in the denominator is bigger, so this one is going to be at y equals 0. Y equals 0, because when the denominator is higher, it's y equals 0. On this one, this is x squared, and this is x to the first, so it's higher in the numerator. So we go back to this one, and we say this one has no horizontal asymptote. All right, let's put all of these skills together, and let's look at this first one. First thing I want to find is the X-Intercept. I usually actually find these first, and I'll show you why throughout as we're graphing. So let's actually go find the horizontal asymptote. Notice this one is x to the first and x to the first. So since they're the same, the horizontal asymptote is going to be dividing the leading coefficient. So it's -3/5. So that means that I'm going to go to -3/5 and have a horizontal asymptote, a line that goes through like this. The vertical asymptote is the place where it's undefined, because it's a line that goes straight up and down. So what would make this one be undefined is if 5x plus 5 equals 0. So 5x equals -5, so x equals -1. So I'm going to have a horizontal asymptote right here at -1. So when I look at my table to graph this at -1, I'm going to see the word error, because you cannot put -1 in for x or you get an undefined fraction. Okay, let's find our X-intercept and Y-intercept. The X-intercept is when you have 0 for y. So what would make this thing equal to 0 is if the top part equaled 0. So -3x equals 15, so x equals -5. So I have an X-intercept at -5, 0. The Y-intercept is when you put a 0 in for x. So I'd have a 0 here, so I get -15 on the top, and a 0 here puts 5 on the bottom, so it's at 0, -3. And then I could go ahead and just find some other values by putting numbers in. So I could try like 0, 1, 2, 3, and I could try -2, -3, -4. I would just put this whole thing in my calculator, and when you do that, you get a graph that looks something like this. And I would let you use a graphing calculator for that. Okay, let's look at the next one. I'm going to find my horizontal and vertical asymptotes first. Horizontal, I see that I have a degree is bigger on the bottom, so it's going to be at y equals 0. So I have a horizontal asymptote right here. The vertical asymptote is the one that's undefined, the line that goes up and down. So that's where x squared minus 1 equals 0. So x squared equals 1, so x equals plus or minus 1. So here's -1, and here's +1. So what this means is if I look at the table, at -1 I'll see error, and at +1 I'll see error. And then I can try numbers in between. And just for time on the video, I'm not going to show you how to do that on the calculator. You can, but if I tried 0, I would get -1. At 1/2, I would get 4. At -1/2, I would get 1.33. So the graph inside here looks something like this, because the y-intercept, when I put 0 in for x, I get -1. So it actually goes through here. And when I put 0 for y, I get -1/4. And when you punch it in the graphing calculator, it kind of looks something like this. I'm not so worried about that right now because the graph will draw in for you on Delta Math. Let's do one more, and let's just see if we can find all the parts. So let's go with horizontal and vertical asymptote first. I see that vertical asymptote is an undefined line. So if I make x squared plus 1 equal to 0, I get x squared equals -1. And when I square root, I get imaginary. And since this is imaginary, that means there's no vertical asymptote. So when I make my table of values, all numbers will work. The horizontal asymptote, I see this is x to the 0 power on top, and that's x to the 2nd power on bottom, so it's bigger on the bottom. So my horizontal asymptote is going to be at y equals 0. So it looks like that. The x-intercept is when I put 0 for y. So if I make this fraction equal to 0, I think what value could I put in that would make this 0? And there really isn't one, because there's no x in the numerator, so there is none here. The y-intercept is when I put 0 for x. So if I put 0 here, I get 4 over 1, which is 4. So 1, 2, 3, 4. And then, just to save time, and I think my bell's about to ring, so 0, 4, if I put 1 in, I would get 2. And if I put 2 in, I get 0.8. If I put -1 in, I get 4. If I put -2 in, I get 0.8. So this graph looks something like this. And it never touches the line y equals 0.